All right. So today we are going to talk about powers of zero, and then we're going to talk about power of a power or power rule. So we'll get into both of those. This should be a pretty short video. Once we talk about this, I'll also post the IXLs that go along with this in the Google Classroom. There will be another video either tomorrow or Wednesday talking about negative powers, and that will be it for the new content for this unit. So it'll mostly just be practices for a little bit. And then we've got a lab later in the week that I will give you guys the data for, either in just a document or in a video. But for right now, we're going to focus on powers of zero. So to introduce this, what happens when we divide 3 squared divided by a 3 squared? Now, we could do this by hand, right? Pretty easily. 3 squared is 9 divided by 3 squared, which is 9. That gives us 1. So we know 3 squared divided by 3 squared is 1. Based on the division law, the answer should be 3 to the 2 minus 2, or more simply, 3 to the 0 power. Can we actually raise something to the power of 0? And the answer here is yes. So the way this works is the exact same way that I was just talking about. But instead of multiplying it up to 9, we can rewrite it as a fraction. So we can do this with any powers. And we can just cancel these out. Remember, when you cancel out fractions, you're left with 1s in place of them. So basically, you have 1 times 1 on the top, 1 times 1 on the bottom. And this gives us 1 over 1, which is just 1. And this would work for anything. So if we did 5 to the 4th divided by 5 to the 4th, again, using power rule, that's 5 to the 4 minus 4, which is 0. But if we write it as a fraction, we have 5 times 5 times 5 times 5 over 5 times 5 times 5 times 5. We can cancel each one of these out, leaving us with 1 over 1, or 1. So basically, any number raised to the power of 0 equals 1. There is one exception, and that is 0. So 0 to the power of 0 is actually undefined. And the reason for this is the exact same reason we were just talking about here. So let's say we had 0 squared divided by 0 squared. This would be equal to 0 times 0 over 0 times 0. And when you have 0 on the denominator of a fraction, that's a problem. You can't divide by 0. That doesn't work. When we talk about negative exponents, it turns out that 0 to the negative power is also undefined. But basically, 0 to any positive power is equal to 0. You cannot have 0 to the 0. That is undefined. So that's just an important little side note for the powers of 0. But otherwise, everything else will be equal to 1 when you raise to a power of 0. Another type of problem we can look at is a power of a power. So this is when we take an exponent, like 2 squared, and we raise the whole exponent in parentheses to a power. So in this case, we're doing 2 squared squared. To solve this, we can expand it out and see what it looks like. So we expand what's inside the parentheses first. So we expand that into 2 times 2 squared. 2 times 2 squared would be, we're going to take this. The squared tells us to multiply it by itself. So we can rewrite that as 2 times 2 times 2 times 2. This is this part that's underneath or in the parentheses here, squared. Now, obviously, with this one, we can multiply it out, right? We could go 4 squared, 4 times 4, same idea. We can rewrite that without the parentheses because it doesn't matter anymore. We're using multiplication. And then rewrite this in exponential notation, and we get 2 to the 4th. So 2 squared squared equals 2 to the 4th. Here we can look at another problem. So we've got 3 cubed cubed. So we're going to start same way. We're going to expand it out, starting with what's in the parentheses. So now we have 3 times 3 times 3. That's this 3 cubed, just rewritten in expanded notation. And we're raising that to the 3rd power. So we need to take this whole thing and multiply it by itself 3 times. So we rewrite that as 3 times 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 3. Same idea. Now that we have it all as multiplication, the parentheses don't actually matter for our order of operations, so we can just rewrite it as a bunch of 3's multiplied by each other. If we count these out, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can rewrite that as 3 to the 9th. What you might have noticed was when we had 2 squared squared, I know there's a lot of information on the screen, that was left with 2 to the 4th. When we had 3 cubed cubed, that gave us 3 to the 9th. As it turns out, when we raise a power to a power, what we can do is just multiply the 2 different powers. So a to the b in parentheses raised to the power of c is equal to a to the b times c. So in this case, 3 to the 4th to the 5th power. All we have to do is go 3 to the 4 times 5, which is equal to 3 to the 20th. So pretty simple. All you're doing is multiplying the two powers together. And this is when you're raising the whole thing in parentheses to another power. So for 7 squared to the 4th, 7 times 2 to the 4, which is equal to 7 to the 8th. And we can break these down and show, or work them all out by hand too. This one's not too bad, so I'm going to use the 7 squared to the 4th one. We'd take it, we'd make it 7 times 7 in parentheses to the 4th, which is 7 times 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 7. And if we count these out, we have 1, 2, 3, 4, 5, 6, 7, 8. So it would give us 7 to the 8th, which is what we had right here. And that is all we're going to talk about in this video. It's pretty short. I'll do a quick review of all of our different power rules at this point. So I'm going to use x for my number. Anything raised to the power of 0 equals 1, except 0. You can't raise 0 to the power of 0. That doesn't work. Apparently my camera froze, so that's going to be awkward. Then we have x to the a times x to the b. This is a multiplication rule. This is equal to x to the a plus b. So if you're multiplying two exponents with the same base, you add the powers together. For division rule, if we have x to the a divided by x to the b, that's equal to x to the a minus b. And then if we have x to the a all raised to the power of b, you get x to the a times b. Easy peasy. So when we're multiplying exponents, we add them together. When we're dividing exponents, we subtract them. And when we're raising an exponent to another exponent, we multiply the exponents together. And that's it for what we're covering this week. I will post the Excels into the Google Classroom to go along with this. And then tomorrow we'll have a new activity and a short video that goes along with that as well. Let me see if I can get this. Stop sharing.